Welcome to this short review on option value drivers. We start with a visual example. Assume you have bought the forward at the forward price F. With a forward contract, you will buy the underlying at expiry and pay the forward price. If you wanted to buy the underlying at expiry, you could alternatively buy a call option, which would allow you to buy the underlying at the strike price. Comparing a forward with a call option, we can see that if the strike price is lower than the forward price, it is more attractive to buy the underlying through the call than through the forward. Such an option is called an in-the-money forward option. An in-the-money forward option has parity value because exercising the call is more attractive than using the forward. Parity value therefore depends on where the strike price lies relative to the forward price. A call option has parity value when the strike price is below the forward price, otherwise its parity value is zero. But unlike a forward, an option gives the holder the right to choose whether to exercise or not. Before expiry, this flexibility creates additional value, which we call the volatility value. It represents the value of the option's optionality. An option therefore has two value drivers: parity value, which measures whether the strike price is more attractive than the forward price, and volatility value, which measures the value of having the right to choose. Parity value compares the strike price with the forward price. In-the-money forward options have positive parity value, while out-of-the-money forward options have none. For a call, parity value equals the forward price minus the strike price discounted to today. For an in-the-money put, the parity value equals the strike price minus the forward price, all discounted to today. Note that no option model is needed to calculate parity value. Volatility value depends on the volatility of the underlying, the moneyness of the option, and the time to expiry. All options, whether in, at, or out of the money, have volatility value. However, to calculate volatility value, we need an option valuation model. To summarize, in-the-money forward options have the highest total value because they contain both parity value and volatility value. Out-of-the-money forward options have the lowest total value because they contain only volatility value. At-the-money forward options also consist only of volatility value, but they have the highest volatility value because the right to choose is most valuable when it is still uncertain whether the option will finish in or out of the money. Now that we have refreshed the two value components and their drivers, let's work through a simple numeric example. Consider a call option with a strike price of 95 and 6 months to expiry. The option is currently trading at the price of 10, while the underlying trades at 100. The funding rate is 4% per year, and the underlying does not pay any dividends or other benefits. Your task is to calculate both the parity value and the volatility value of this call option. We start with the parity value since no model is required. Because parity value is measured relative to the forward price, we first calculate the forward. With a spot price of 100 and a funding rate of 4%, the 6-month forward price is 102. For the call option, the parity value is the present value of the forward price minus the strike. This gives us a present value of 7 or 6.87 once discounted to today. To find the volatility value, we use the observed market price of the call, which is 10. Since the total option value equals parity value plus volatility value, the volatility value is 10 minus 6.87 and therefore 3.13. We want to trade options on the S&P 500 index. Today is June 1st. Since we are interested in the December options, we first look at the December S&P 500 futures contract. The ticker is ESZ5. The December future is currently trading at 6,672.25. We then look at the December option monitor from the Chicago Board of Options Exchange. The table displays call prices on the left, put prices on the right, and the available strike prices in the center. For each strike, the market quotes bid and ask prices. The ask price is the price at which you can buy an option, while the bid price is the price at which you can sell it. Now look at the call prices on the left side of the option table. Calls with lower strike prices appear at the top, while higher strike calls are shown further down. Notice that the lower strike calls are more expensive than the higher strike calls. Does that result seem intuitive to you? How about the put prices on the right? The puts with the lower strikes are at the top of the table and have lower prices, while the high strike puts are more expensive. This makes intuitive sense. The right to sell at a high price is more valuable than the right to sell at a lower price. We have highlighted 6 options with 3 different strike prices. The 6,675 strike, highlighted in yellow, is approximately at the money forward. The lower 6,375 strike is highlighted in green, while the higher 6,975 strike is highlighted in red. Based on the current forward price, can you determine which of these call and put options are in the money and which are out of the money? The green call with the lower strike is in the money relative to the forward. As a result, the corresponding green put with the same strike is out of the money. Conversely, the red put with the higher strike is in the money, which means that the corresponding call with the higher strike is out of the money. The options at the 6,675 strike are approximately at the money forward. Let's look at the green in the money call with the 6,375 strike. The option is quoted with a bid price of 396.9 and an ask price of 397.5, giving a midpoint of approximately 397. To estimate the parity value, we compare the strike price to the forward price. The difference is roughly 300 points. Discounting this amount at 4% for 6 months gives a parity value of about 294. The volatility value is then simply the difference between the market price and the parity value. With a mid-market price of 397, the volatility value is approximately 103. Now consider the green put with the same strike. Since it is out of the money, it has no parity value and consists entirely of volatility value. With a mid-market price of about 102, its volatility value is approximately 102. It's always good to visualize something in a graph. So let's use an option diagram to visualize the decomposition of the total value of the green in the money call. The total option value can be split into 2 components. We can perform the same exercise for the green out of the money put. In this case, the diagram makes it clear that the put option consists entirely of volatility value, as there is no parity value. Returning to the option table, we now decompose the red in the money put with the 6,975 strike. The parity to the forward is again about 300 points. Discounted to today, this gives a parity value of approximately 294. Based on the mid-market price of 351, the remaining volatility value is 57. For the red out of the money call, there is no parity value. Its full value is volatility value, which is about 53 according to the market price in the option table. We can again visualize the option value decomposition using the diagrams shown here. First, the out-of-the-money call consists only of volatility value. Then, for the in-the-money put, the total option value is split into parity value and volatility value. Finally, we decompose the value of the at-the-money forward options. Since both the call and the put are at the money, neither has any parity value. As a result, the entire value consists of volatility value. Based on the market prices, the volatility value of both options is approximately 182. We can again look at the option diagram to visualize the value decomposition. First, consider the at-the-money forward call. Its entirely value consists of volatility value. The same is true for the at-the-money forward put. As the diagram shows, its value is also made up entirely of volatility value. Now take a look at the decomposition of our 6 option prices. It appears that the volatility values of calls and puts with the same strike are either identical or very close to it. At this stage, it is difficult to tell whether this is a coincidence or a general pricing relationship. We will revisit this question later when we discuss put-call parity, which provides a deeper explanation for this observation. All we have to do now is summarize the key takeaways from this review. We learned that every option value can be decomposed into 2 components, parity and volatility value. This distinction is an important concept and will be very useful as we continue our analysis of option pricing.